All right, this is going to be a quick review of radical rules, so simplifying radicals. Radicals are like square roots. We call them radicals though because they don't always have to be square roots. They could be cube roots, quadrant roots, whatever, how you say that, roots with different numbers. You'll see that later in future math classes. So if we have, for example, the square root of something simple like 16, that's really easy. The idea of a square root is that it's the inverse operation for a square. So if you square a number, like you square the number 5, 5 times 5 is 25. So we're going backwards. We're saying what number being multiplied by itself will give us 16. And if you recall, 16 is 4 squared. So we can say, okay, 16 is just 4 squared, which means the square and the square root cancel, so the square root of 16 is just 4. But sometimes you're going to have more complicated stuff. Like, what if we have something like the square root of, let's see, 48. The square root of 48 is not a number squared. It's not one of those perfect squares, right? It's really close to 49, which means that if you plug in your calculator and you do the square root of 48, you're going to get something that's really close to 7, because 7 squared is 49, but a little less than. But we don't want that it's almost 7. We want to know what it is. And so instead, we're going to leave it as an exact answer by simplifying it. What you do in this case is you would look for what factors you do know. It depends on what you see. I'll do this a couple ways, but maybe you're like, okay, 48, I know it's divisible by 2. There's nothing wrong with that. You can say it's divisible by 2, that's fine. But the problem with dividing it by 2 and 24 is that neither of those are perfect square numbers. They're just not, right? So what I would do instead is I would look and see if I can think of a number that divides 48 that's a perfect square. And there actually are a couple. Maybe you think of 4. Hey, 48, that's divisible by 4. It's 4 times 12. The thing you have to be careful about here is that actually 12 is also divisible into another set of numbers that contains a square root, right? That contains a perfect square. So let's go ahead and pretend that we did it this way. And then I'll show you one last way that you can do it. You can think of it this way. That means that this is 4 times 4 times 3. And the idea of why I liked 4 is because 4 is 2 squared, right? So this is like the process of like writing it all out. You do not have to write all this out. But the idea is that, hey, this square and the square root cancel. This square and the square root cancel. So both of those numbers can be written outside. Now the 3 doesn't have a square because there's not 2 3s in the factor tree of 48. So it has to stay inside. And then you would have to take this outside the 2 times 2, and you have to write that as 2 times 2 is 4. Now, maybe you were thinking, Ms. Emmons, there's got to be an easier way to do that. There is. Let's say that you had instead, let's go ahead and factor this differently. Let's say that you had factored this as 16 times 3, because it's also 16 times 3. Then you could have almost immediately jumped here to the 4 times the square root of 3, because the square root of 16 is 4. And then the 3 would be left inside because the square root of 3 is just the square root of 3. Square root of 16 is 4. Square root of 3, square root of 3. That's not a nice whole number. So that, let me go ahead and do one more actually. What if you might remember that we had some times where we went like this, right? There was already a number out front. What if you had something like this? So if you have something like this, you'd factor it. This is 9 times 3. I like the 9 because the square root of 9 is 3. So actually, this is a bad example because it's 3 and 3. Let's do something different. Let's do 100. No, I can do simple math. 162. And I picked 162 because this is 81 times 2, right? And I like 81 because 81 is 9 times 9. So what that means is we have the 2 that was already there. So see, this 2 is this 2. And then we're going to have times, oops, let's get my thinner. So times 9, which is coming from right here, the 81, right? 81, the square root of 81 is 9. And then we're going to have the square root of 2, and that is coming from, nope, let's get a different color. And that is coming from this 2 right here, right? It can't, we just have the square root of 2. Can't simplify that any further. Now we can simplify what we have out front in front of the radical. Oops. We have 2 times 9. 2 times 9 is 18. So our final answer would be 18 times the square root of 2. That's a simple, short review of simplifying radicals. If you have questions, please let me know.